Next is creating a Glut display window. So these are the things we have come across already with respect to our lab program, previous lab programs. If you observe the main function, you will come to know. So the first step, you have to specify the initialization parameter to the Opengl with the help of Glut init function. Glut init of it takes two parameter, argument count as well as argument vector. So in ampersand argc as well as argv. Uh, then we have in window position function. So optional it is glut init window position. These are all the functions defined under glut library, so we have to use the prefix glut while writing the callback. So glut init window position, I capital, W capital as well as P capital, so which takes two parameter, uh, top as well as top left position as well as the top left position x parameter as well as top left position of the y parameter it specifies. So glut init window position, top left position it signifies, okay, uh, both x as well as y. So if you specify 0 0, then it will be window will be appended, it will be brought onto the top left corner of the output screen, okay, on the monitor or the monitor. The output window will be kept on leftmost corner of the display if you specify 0 and 0. Then glut init window size, this defines how many number of pixels you want to include horizontally as well as vertically, that is width and as well as height in on the output window, okay. Initially whenever it is brought onto the display, whenever the output window is brought onto the display or on the monitor, how many number initially, later you can go for resizing, that is secondary, but initially how many number of pixels you want to have, that is horizontally as well as vertically, that is set by glut init window size. Then one more function, necessary function. So these are all optional. One necessary function, without that your program will not work, okay. Glut create window, this function callback is must, otherwise output window will not be created only and model will not be displayed. To display the model, since output it is not a this one console based one, instead the window based output we are working with, so window output window is must for that. That's why glut create window, this callback is must. And title of the display window you are supposed to specify, okay. Title can be anything, whatever you specify inside the double quote, that will be mentioned as the title of the, that will come as the title of the window. Then we have glut init display mode. See, display mode, you must be familiar with this statement as well. You can go through the main function, one any of the program, okay, program number 1 2 or 3 as well as 4 you can go through. We are considering a single, that is buffering system for 2D model. Even for the 3D model we consider that as glut single only, but whenever the model contains the animation like rotation and all, experiment number 3 it contains rotating cube, so for that double buffering is must. This signifies about buffering. So single buffering is enough for 2D model, as well as if it does not contain any kind of animation. If 2D model contains animation, then double buffering is required only. If static structure you are going to display, then single buffering is enough. If you are going to display the dynamic structure, then double buffering is must, okay. You have to write glut underscore double. You can go through experiment number 3, okay. Then BLE. Next one, we'll be discussing later in the next modules and all, color system in Opengl. So we are not, by default we are going for RGB color model only, because because of next is about the display window identifier. See, we can have multiple display windows in a program, and each window can be identified separately with the help of an integer. So that can be done by assigning a value for the created display window. So glut create, as you can see here, we can assign a window ID for the window what you have, display window what you have created. Window ID is an integer value or identifier, which is equal to glut create window of title, okay. We can go for creating the multiple window later on, and with the help of the ID we can have access to them. as per our requirement we can make a call for different type of the display window, or where a single program may have different display windows, okay, with for the different models. Then anytime we can terminate the window with the help of the function by making a call for the function glut destroy window. This thing we have not discussed so far. Okay, we have terminated the program with the help of the exit of 0. Okay, glut destroy window of window id. If multiple windows are available, as I said you earlier, so each window is identified with the window id. Just by specifying the window id you can go for terminating them or destroying them. Fine. Then current display window you can set, as I said you, a program, single program may have multiple models, and each model can be displayed by considering different display window with the help of the function glut set window of window id. Okay, this helps us to set the default display window whenever there are multiple display windows are available. We can go for reshaping the window, display window, as per the width height specification. So for that we have to make a call for the function, built-in function glut reshape function. You can go through the experiment number 3 as well as 4. There is a callback from the main function glut reshape function, okay, which takes 5 or 6 different parameters for the 3D model. As you can see, experiment number 3 of the of our lab program, that is spin cube, or even you can check experiment number 4 as well. Okay, color cube model. For that, sorry, yeah, glut reshape function callback is registered from the main function. Okay, with respect to sufficient number of parameters, left, right, top, bottom, as well as near, as well as far. Fine. This resets the or resizes the display window as per our requirement. Next is the sub window concept. Within a selected display window we can set up any number of sub windows. Okay, any number of second level window, they are called as second level display. So all sub window they are called as. And we have a built-in function in OpenGL for creation of the sub window. Glut create window is used to create the main window, and for sub window it is glut create sub window. Hope it is visible. So observe here, glut create sub window is the name of the function. Then it takes a parameter, see, window id of the main window, then bottom left level, that is bottom left value of x, y, then width as well as height. If you know these 4 parameters, then you can set the rectangle. Okay, bottom value, that is x minimum value, then y minimum value. Apart from them we have to take the width like viewport only, width as well as height. If you know the width, then x maximum, okay, you can find, as well as y maximum also you can find if you know the height means. So these are the 5 parameters required for that, for defining the sub window. Okay, sub window, for that main window id is required, for which main window it is to be acted as a sub window, followed by what is the size of the sub window by taking these 4 parameters. Very simple concept. Next is displaying the model onto the screen. While displaying the model onto the screen, some module or some function in our program can define the display model, or can define the object. So we have to make a call for the object. This is the function name of the function, where exactly you are defining the coding part, where exactly the coding part existed for the object. Okay, any of the program you can check. So glut display function followed by my display or whatever, which defines the object you have to make a call for. That will bring the object onto the output window. So far we have discussed about the window, isn't it? Window, sub window, as well as the other function, resizing the window or reshaping the window, positioning the window and all. Once the output window is positioned and it is resized, once everything, all the requirements are fulfilled, next step is what? Your program to bring the model, the defined model, on top of the window existed at appropriate position, isn't it? That is done with the help of the callback. This callback must be registered with the main function. Again, it is defined by glut library, so the prefix we have to use glut, glut display function func, okay, where D is capital, F is capital, name of the module or name of the function where exactly the coding existed for the model. Fine. Whenever a model is updated, you have to display the updated model onto the window, display window, with the help of callback glut post redisplay. This you can see at the end of the main function, right? So the output window should retain the model. If it is a static image, of course there is no question of updation. At every regular interval model will be updated, but there is no, since it is a static model, there is no movement for the model and all. The same model will be kept repeatedly on top of the output window. If it is dynamic, then updated model should be kept on the output window, right? That is done with the help of the function glut post redisplay. One more callback we have, that is registered under glut library only. So it is to be, once again it is to be this function should be registered with the main function, that is to retain the output window on top of the monitor, glut main loop. Even you can find this glut main loop as the last callback from the last function from our main function. You can go to see any of the lab experiment, okay, glut main loop, which is nothing but the callback registered under glut library. So it is to be registered with the main function, which will retain the output window on top of the monitor, so that continuously you can see the output, okay. That is what about the application of the callback glut main loop. Another important callback registered under glut library, that is glut idle function. Whenever nothing is happening, then default idle function will be called onto, the default idle function will be called and necessary action will be taken. Best example for idle function is the spin cube. Spin cube, when there is no user activity, what it does, for the first time you will simply click on the particular option to get the output, right? You are not providing any kind of inputs to the system. You just check the model. Since we have implemented the that is for the spin cube, we have implemented mouse, we have implemented keyboard interaction, even we have tried with the menu as well. You don't provide any kind of input. What it does, it will not display the static image. Instead it will display a dynamic image, right? Keep on rotating along with z axis. The model, the spin cube, or the cube what you have defined, will be keep on rotating along with the z axis. That is what we have defined, right? So whenever no action or no input is provided by the user, you have to execute the default action. The default action is defined by the idle function, okay. That is what one of the use of the idle function or application of the idle function. By making a call for the idle function, that spin cube is the user defined function what we have defined for continuous rotation. That spin cube is called by or with the help of the function, say callback, say idle function, glut idle function. That is what one of the application of the idle function is. So students, this ends our module 2 as well. Please concentrate. This completes our module 2 as well. Two lab experiments are based on this module. One is a scanline fill area algorithm, which I will be explaining while explaining the lab program, and one more experiment that is based on the clipping, the last topic, 2D weaving, what we have discussed in the previous video, that thing. So one experiment, Cohen-Sutherland line clipping algorithm. The basics of that I will explain in the next video, the actual coding part. Okay, let us see in the classroom later on. So please concentrate. Very simple experiment it is. We have to define a clipping window, then we have to clip the particular object. It's a simple 2D model. So you are supposed to draw a line segment. You have defined a clipping window, then just observe whether the line segment what is drawn which passes through the clipping window or not. If it passes through the clipping window, the outer region you have to clip off. That's it. And you have to redefine the particular line segment. Like yesterday in the previous session we have discussed that mountain I said, right? That mountain, only some of the portion of the mountain we have selected and rest of the portion we have clipped up in the same way. Okay, very simple experiment it is. Let us discuss that. later on. The basics of that I'll tell you later on. Fine. Okay, this completes your module 2. The main thing here is the first concept, the first few concepts, like defining the polygon, then identifying the interior region as well as outer region of the inner region as well as outer region of the polygon. Those things, winding, number, test and all, we have discussed in the last month only, that is during pre-lockdown period. We have discussed that in the classroom earlier. Okay, later I have switched to module 5, because module 5, earlier in the previous session we have discussed something about the module 5, right? Almost 70% of module 5 I have completed. Only about the curve it is pending, but to study about the curve, these geometric transformation functions and all you should be familiar with. So more than 50%, yeah, about 70% of module 5 I have completed, so that easily you can answer one question from that particular module. Then I have switched back to module 2 these days, and now this is what the last topic. Okay, 2D weaving. So that is what the conclusion about the module 2. All the topics from module 2 are covered. Okay, almost 3 modules are completed by the time. So I'll be continuing with the 4th module. That is, for us it will be 4th module. As per the syllabus it will be module 3. So it is the continuation of the 2D transformation. So we will be discussing about the 3D transformation in the next session. If you have any doubt, you ask. Okay, watch the videos repeatedly, note down the things. Thank you for watching.